N is an integer greater than 0. Integers greater than 0 are numbers like 1, 2, 3, 4, etc. Quantity A is the number of different prime factors of 9 times n, 9 times any one of these. Quantity B is the number of different prime factors of 8 times that number. We have to see which is greater, or if we can make a conclusion at all. And I'm going to use this video to remind you how the factor tree works. We are going to try plugging in some numbers. I'm going to go with n equals 3 for starters. Okay, we're going to use n equals 3, and we're going to see if we can make a conclusion based on that. What does that say about quantity n? Well, now quantity A. Quantity A is 9 times n. That means it's 27. What is the number of different prime factors of 27? Well, we do the factor tree. Figure out what number times what number equals 27, and don't use 1 in 27. Well, 27 is 3 times 9. We can go down any of these branches. We can go down to the 3 and think, is there a number that multiplies with another number to get 3 besides 1 and 3? And the answer is no, there isn't. Okay, this branch is said to be terminal. Okay, this is a prime number. That's what we're looking for. That's one of the prime factors then, 3. Meanwhile, 9 is the result of the product of 3 and 3. Both of these branches are terminal. Now consider how this tree ends in 3 branches, but that does not mean there are 3 different prime factors. All 3 branches end at the same number. The only prime factor here is 3, so there is 1 prime factor. So for the time being, quantity A is equal to 1. If we use 8n, then we have 8 times 3, which is 24. And we're going to do the same thing with 24. Two numbers that multiply together to make 24 are 6 and 4. The 6 can be split off into 2 and 3, both of which are terminal numbers. The 4 can be split off into 2 and 2. Here we have 4 branches, but they are really the same 2 numbers. Okay, 3 instances of 2, 1 instance of 3, but that means that the number of different prime factors is 2. So it would appear that quantity B is winning, but I don't really trust it. Instead, I'm going to try a different number. Any number will do, but I'll have to make it easier on myself. How about n equals 4? Remember, just don't use 0 or 1, and very often don't use 2 either. Sometimes there are trap answers. So what if n equals 4? Well, now 9n is 36. 9 times 4 is 36, and 36 can split off into 6 and 6, each of which can split off into 2 and 3 by the logic I walked through earlier. Now this time the number of unique prime factors of 9n is 2. Okay, because every number here that terminates is either a 2 or a 3. So this time we get 2. What about over here when n equals 4? Then 8 times 4 is 32. 32 could be 16 times 2, that is the end. But 16 is 4 times 4, but each of these 4s is made up of 2s. Here we have 1, 2, 3, 4, 5 instances of one unique prime factor. So there is only one prime factor of 32. Therefore, the quantity B is 1 in this case. Clearly, since we've chosen 2 different numbers within the constraints of the problem, and we've gotten 2 completely different results, we have to say that the relationship cannot be determined from the information given.